We got a little symmetry here. Hopefully this should go pretty quick. A lot of you have been doing symmetry since you were in elementary school. So this should make sense. And hopefully we know that symmetry means it's the exact same on both sides. And for example, we could have a line of symmetry, which is a line that's drawn through a plane figure. So that the figure on one side is the reflection image of the figure on the opposite. Basically, if I draw a line through a shape that on both sides of the line, they look identical. It's like a reflection. So for example, in this triangle, this is really an isosceles triangle here, I could draw a line right through the pipe here. That would be a line of reflection, just like that. If it was an equilateral triangle, if all three sides were congruent, then I'd be able to have three lines of reflection, or three lines of symmetry, going through all the vertices. But in this case, it's an isosceles, so this just has that one line of symmetry. If I try to draw another line through that vertex, it would be just a little bit off. It wouldn't be quite reflection on each side. So there's only one line of symmetry here. Whereas if I have a square, I have a line right down the middle and a line through the middle horizontally. So there's two. But if it's a square, I also would have diagonals, right? Oh, bad line there. Lines are a little sloppy, but something like that. Yeah, I'm not the best drawer in the world. So in this case, this would have four lines of symmetry. A rectangle would not have those diagonals, but a square would. So first of all, let's take a look at this parallelogram. What do you think? Does this guy have any lines of symmetry? Diagonally, I don't think so. If I tried drawing in one, what if I drew a horizontal here? And I folded this bottom piece up. If I folded this bottom piece up, would that be symmetrical? Is that a reflection? No, it's not. What about vertically? Can I put a line vertically? Even if I angled it kind of like this, if I folded it, now if I folded this top corner would overlap over here. So that's not a reflection. That wouldn't be a line of symmetry. What about diagonally? What if I put one going through here? If I folded this piece, it would fold over to here. It wouldn't quite match up. So I don't know. If I just look at it quickly, I would probably think that there's some lines of symmetry. But as I look closer and maybe actually even cut this piece out on a sheet of paper and started folding, I would not have any lines of symmetry. So here there are no lines of symmetry. So none. We also have rotational symmetry, which means as I rotate an object about a center, that if I can rotate it back to its original shape, it has rotational symmetry. So taking a look at this square. For example, I better get it to what its starting point is right here. Okay? So this is my original shape right here, this diamond square. Well, if I rotate it 45 degrees, so I take this and I rotate it 45 degrees, it's now looking just like this. It's not quite rotational symmetry because it has to look like the exact start, the exact shape that it was in the first place. But if I went another 45 degrees, now I'm at 90 degrees, and if I notice with my shapes, they are identical. So those would be some rotational symmetry. So the second one is not rotational symmetry, right? If I took my green box here and I rotated it 45 degrees, my green box, 45 degrees, not quite, but if I go 90 degrees, boom, there we go. I just went 90 degrees. So that would be, I got one. Well, if I rotated it another 90 degrees, now I'm at the diamond again. So there's two things of rotational symmetry. If I rotated it another 90 degrees, a third time, I'm still at that diamond. If I rotated it one more, it would finish and it would go all the way around in the circle. So really it goes 4 times to get back to the start for its rotational symmetry. Okay, it's kind of, hopefully we got a grasp on it. We'll look at some examples to get a better understanding. So it says, state whether the figure has rotational symmetry, right, yes or no. Basically, if I can rotate it about its center and make it look like the original image, it has a rotational symmetry. If so, copy the figure, locate the center, I just located it, and state the order and magnitude of symmetry. Well, the order is how many turns? How many turns to make it all the way through the circle? And the magnitude is the degree of each turn. So 360 all the way around, I gotta figure out how much each one is. Well, if I take a look here, right now I'm at 0 degrees, right? So if I start rotating this guy, there's one turn. So I got one turn and I'm back to the start. I know my center point wasn't very good there. Okay, so basically, let me bring this back to where it was. Just like this. So I went one turn, and now my top point is at this left side. 2 turns would bring it here, 3 turns would bring it here, 4 turns here, and 5 all the way back to the beginning. So this has an order of 5 and a magnitude of, well, it took 5 turns to go 360 degrees. So I could break that 360 divided by 5 to end up with 72 degrees. So that would be its magnitude. How about this shape? Well, just think if I started rotating it, could I get it back to its original image? Let me just start messing with it. If I started rotating, yeah, I believe so, right? I can get this back to its original image as I start rotating. Okay, so let's go ahead. So this has rotational symmetry. So the center's about right here. Think about how many turns. Well, I'm just going to grab this piece. 1 turn brings it to here. 2 turns to here. 3 turns back to the start. So it's got an order of 3 and a magnitude, well, it took 3 turns to go 360 degrees. So how much is each turn? 120 degrees. So pretty straightforward. Just taking a look at how many turns and then break it up into the parts of 360. Well, what about this guy? If I take a look and start rotating it, it looks like, yep, it's going to rotate. It's going to have the exact same image, right? So let's take a look how many turns it's going to take. Well, 1 turn, 2, 3, 4, 5, 6, 7, 8 total turns. So it's got an order of 8 and a magnitude, well, it took 8 turns to go 360. So that leaves us with 45 degrees for each turn. There we go. So that's a little bit about our rotational symmetry. Last couple things. We also have plane symmetry, which basically means if I can take a sheet of paper and cut an object directly in half, it would have plane symmetry. And we have axis symmetry, where if I stuck like a pole or a pencil in a shape and spun it, so if I, like this cone here, I stuck a pencil in the middle of it and started spinning it around in circles, as long as it would keep the same shape as I spin, it would have axis symmetry. So take a look at these 2 objects here quick. Looking at this sphere. So basically if I took a piece of paper and I cut it right through the center of this sphere, it would cut it in half. Yes, this guy has plane symmetry. But what about axis symmetry? If I took a pencil or a pole and stuck it right in the center of this sphere and started spinning it around, yeah, it would have axis. It would be the exact same shape as I spin that ball. What about this sandal here? I don't think there's any sheet of paper I can cut this in half, right? It's not symmetrical if I cut a sheet of paper through this. So no, there's no plane symmetry. So no plane. What about axis? If I stuck a pencil in this somewhere and started spinning it, would I have the exact same shape as I spin? No, it would be different the whole time, right? So no axis. So there are neither. I suppose I could have put both for this first one. It would be fine as well. So there you go. I think that one's pretty straightforward. And there you go. That's all you need to know about symmetry.
Thanks